Okay, hi everyone. So we have a lot of material to get through and not a lot of time, so I'm going to rush a little bit. This is an actual talk that I gave at PyData Delhi as a keynote, but it didn't get recorded, so I asked the PyData Delhi chairs if I could present it again so we can get a recording of it. A lot of work has been put into this talk, but I want to give you the context of this talk. So I was online on one of those link aggregator sites like Hacker News the other day, and I saw a link to the 500 best Python talks, and it was some really junky domain like bestpythontalks.biz or something. And I went through it, and I looked for the best talks, and I've given probably, this is like my 95th conference talk in the last 5 years, so I thought maybe I'll find one of my own there. Be a nice little ego boost. So I look, intro Python talks, nothing of mine. Talks about CPython, nothing of mine. Talks about NumPy or numeric or scientific computing, nothing of mine. Talks about embedding Python 1 interpreters into Python 2 interpreters, into Python 3 interpreters, using linker namespaces vis-a-vis DLM open, nothing. I'm the only one who's ever done that. I'm not even listed under that one. And so I said to myself, the ego and the vanity of this, maybe it doesn't matter. And so I parked that for a second. And then, a couple days later, there was another link on Hacker News, and it was, please post your favorite YouTube videos of all time, the best computer science or programming talks you've ever seen. And I was looking through that list, I saw all these seminal presentations that had really changed the face of computer science, of software development, and I was hoping none of my talks would appear on that list, because I don't think I've made a contribution that significant. And thankfully, none of my talks appear there. But it reminded me of something very important, which is I don't care about the ego, I don't care about the fame. I just like to have a little bit of fun. And so I thought, why don't I put together a talk that will never appear on one of those lists ever, because it's the most garbage, useless talk ever. That's what this is. So before we get started, we're at PyData NYC. It's Thursday, October 18, 2018. This is ... One thing that I've thought about, you give enough talks, you always think about doing a Twitch stream like Scopats here has tried doing, or a live cast or a webcast. But the problem with doing those on YouTube is you have to be really good at that part where they say, please like, subscribe, bell, and comment. And I can't bring myself to be that enthusiastic. So here's me on Twitter. You can follow me or not, I don't really care. But if you'd like to, go ahead. This is a talk. OK. So one thing that's really important about this talk is there is no theme to this talk. Please, 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 there is no theme to this talk. You may look at this talk and say, well, there's obviously a theme. It's about how the joy of discovery, the joy of digging deep into a problem is something that nobody can take from you, that there's a certain pleasure in understanding something very fully. And only when you think you have mastered that topic, you realize there's even further to go. Nope, that's not the theme. This talk has no meaning. But it is contextualized in terms of a story. And I know many of you out there are very precocious, and you may have had an experience just like the one I'm about to describe. So imagine your first day of your first job. You did a PhD, you did a master's, you did a boot camp in computer science. You show up to work, and your boss says, welcome to our company. We're so glad to have a young kid like you joining us today. We're a company, we do scientific computing. In fact, we work in the optical industry and in the fiber optics industry. We really need people who know about software, so it's great that you learn Python in school. We're trying to transform this industry. I'm going to start you with a really simple task. We'll work on the back end of our system. Maybe we're building reconfigurable optical add-drop multipliers, ROADMs, or some other optical hardware. But we'll start with something kind of simple. Why don't you write a function that converts wavelength to optical frequency? And you say, oh my goodness, are you serious? Like, I just did a PhD and you're asking me to do that? That's just C divided by the lambda or C divided by the nu. Serious? But your boss comes to you and they start you off with a little code sample, and the code sample looks something like this. And they say, you know what? What we want you to do, if you're following along, is write wavelength to frequency. It takes a frequency, and just fill in the blank there. And I'll put a comment up here to tell you what I'm working on. Converts wavelength to optical frequency. And we want you to fill in the blank there. And you're looking at that and you're like, really? My first day? Did you not read my resume? I can do a little bit more than that. And your boss comes to you and he says, or she says, because remember, condescension transcends gender. Please, come on, take the task and do it. And when they write this out, they might write it out like that, or they might write this. And we'll save this. You can see it runs on the side, not implemented error. Or maybe they're a little bit cleverer than you thought, and they did a doc string here instead of a comment. And that works as well. Or they might do this. And you look at that and you say, that's kind of weird. What is that? ... And you're thinking about the task and you say, oh my goodness, they're really asking me to do this. And so you say, well, you know what? I'm pretty smart. I'll just do this. Right? And if they ask me to actually give it the name they said, I'll just do that. Or you know what? I'll just do that, right? And you know what? I'm so smart, I could just do this because I know the two formulas are the same, right? It's either c divided by lambda or c divided by nu. It's the same either way. So it's not too hard. But you know what they're really asking for. What they're asking for is something that looks more like this. You know, they want you to write it all the way out, the wavelength to the frequency, converts wavelength to optical frequency. And, you know, they're really hardcore on documenting everything. So maybe we actually even use Sphinx here. So you do param, W, wavelength. Oh my goodness, this is so tedious. I can't believe I spent that much money on grad school for this. Seriously, and you returns the optical frequency. And it feels like this has taken you an hour. And you look at the clock, and it's taking you about 3 minutes. And you're like, okay, you know, they asked me to do both versions of it. So, you know, we'll just do both versions. And this is just too much, right? This is too much. I can cut and paste my way to completing this assignment. And you just wonder, what kind of choices have you made in life to lead you to here? There we go. Did I do that right? And you save it, and it works, and it kind of does what you think it would do. But that one question stays with you. That ... How did that work? That was kind of weird. And so you're precocious, and you're curious, and you're not really fulfilled by the task that you're doing here, because clearly it took us about 30 seconds, and I'm on stage right now. So you start digging. And the first place you dig is what? Documentation. But you're a smart kid. So you know documentation is not enough. You always have to dig into the code. But it makes sense to start with the documentation. So maybe you start with the documentation, or maybe you start by just Googling it, and you find this post from 2006, Guido van Rossum. He's responding to Greg Ewing saying, Py3k, this is when Python 3 was just coming out, make ... a generally legal expression. And you might track this a little bit further, and you might see this post from 2 years later, where Raymond and Guido are discussing the ... And Guido says, some folks thought it would be cute to be able to write incomplete code like this. And so you say, okay, so my boss wasn't doing anything too crazy. I mean, they intended this, but you still are very curious about that ... Now, you may have seen something like that ... before. You may remember from, you know, when you type it into your Python interpreter, you get this ellipses, and you may have seen something like that before. You can kind of guess that you've seen similar ideas to this with your true, false, and none. And you may have even seen this in use. You know, if you take a NumPy and D array that represents a matrix like this, you know, a 5x5 matrix, you know you can index it with your fancy indexing, and you can do like that, and that gets you, whoops, let's do the first row. That gets you the first row. And you know if this happens to be a 3-dimensional structure, so we'll make this a little bit bigger, like that. You can do this kind of indexing. Similarly, you can do 1 ... But that's kind of the same thing as doing 1:, which is maybe a syntax with the slice operator or the slice object that you've seen before. And you may even know that if you just do 1 here, you get the same result. But there's something kind of special to this ... at least in NumPy, because while that gives you one of the planes of this cube, that gives you a different plane of the cube. So there's something kind of interesting how NumPy actually deals with this ... It's not quite equivalent to the colon, but you know, if you were really cared about it, you could read through the documentation for NumPy, but you're really just curious about this syntax, because it turns out that this is valid Python syntax. And what's interesting is that means that this is valid Python syntax, right? And if that's valid Python syntax, then we know that that's valid Python syntax. Now, if that's valid Python syntax, then we know that this is valid Python syntax, right? And we can space that out to make it look a little bit better. And we know that this is valid Python syntax as well. Now we're beginning to look like something kind of cool. And we know we can just keep going and going. And if we really want to, we can even determine that we could add in a couple of underscores here and here. Except that'll break because when it tries to actually compute that annotation, it'll try and do the dotted lookup with an underscore and an attribute, and ellipses doesn't have one of those. But you're smart. You follow Python dev. You know we were in Python 3.7, so there we go. We can say from future import annotations, move that to the top of the file, and that's valid Python syntax as well. And that's kind of cool. And you try this a little bit further, and you say, well, let me try something simpler. How about that? That's not valid Python syntax? Whoa, what's going on here? Let's try something even simpler. That's not valid Python syntax? Something kind of strange is happening here. But you look at the time, it's 5 o'clock, it's time to go home. Let's visit this another day. You come back the next day and they look at the code review and they are ebullient. They are so happy. Oh my goodness, we're so happy we hired you. You know, they said we don't necessarily need somebody who's young, we need a senior programmer, but you knocked that to wavelength to frequency and frequency to wavelength, you knocked it out of the park. So we're gonna give you a little bit more exposure to the systems we have. You know, we develop ROADMs. We develop full devices. So, you know, you did some back end yesterday. Let's do some front end today. And so we have this little front end, and it has some greetings because, as you may know, the optical industry is a global industry. There's a lot of people who are experts in optical engineering in the US, in Germany, in France, in Italy, in China, and India. And so they start you off with, and let me rewind a little bit because you're seeing some of the results of where we go. They start you off with something that looks like this. And they say, we want you to extend this, and we want you to add some of the other languages that we deal with, right? And here we have English and German, and we think you're smart. You can probably follow the pattern. And you're looking and you're like, oh my goodness, do you not know how much I have in student loans? And you are asking me to fill in the pattern? Oh my goodness. And you call your friend, and you're like, is your job as bad as this? And it turns out it's like that everywhere. But, you know, you say, what can I do? And so you add this in. And you submit that as a code review, and when you come back from lunch, your boss is furious. Because it turns out your boss, irrespective of gender, is French. And they look at that and they say, Sot, ce n'est pas français, c'est franquais. Because it turns out that little C you have there is not the right C if you're spelling French. What you need is a little C with a little squiggly underneath. And this is something that French people care a whole lot about, except when it comes to emails. And we'll talk about that in a second. I don't understand that either. But they say, you know what, you're a new hire, we can requisition some new hardware for you. So you know what we're gonna do? We're gonna requisition a fancy new keyboard, and we're gonna give you a keyboard that does that. Ooh, that's kind of neat. And you have a really fancy keyboard, because your keyboard can even do this. Let's do this. And never switch, okay, and we'll do. Ooh, look at that. And you have. I mean, this is a pretty expensive keyboard they got you, and you can even do this. And this is hard for me to type. This is real. There we go. And if you can't read that, this is just. Let's see. It's just. There we go. That's how you pronounce it. And so you have your fancy keyboard. Now you've implemented quite a bit of functionality here. But you know a little bit more. I mean, you've studied a little bit of Python in school, and you know that you can write it like this, or you can write it like this. And you can pass these as keyword arguments, right? Whoops. And all you have to do is just change these colons to equal signs. And you know that's valid Python too. And that's kind of interesting because any one of these dictionary keys, as long as it's a valid variable name in Python, works very well. And that gets you thinking for a second. Well, that's kind of interesting, right? I mean, because that means that that's a valid variable Python name? That's a valid variable name in Python? That's kind of interesting. And when you think about that a little bit more, you say, well, you know, if that's a valid variable name in Python, then that means I can even do something like this. Right? That's valid Python, right? Nobody here gets the joke. Does anyone get the joke? You get the joke. Yeah. But that's a valid. We'll clean this up here. Actually, make this work. That's a valid variable name in Python. And you say to yourself, well, you know what? This is a really fancy keyboard. I can actually type a ... on the keyboard. So I can actually do that. And I wonder if I visit my example from yesterday, I can do that. No, that's invalid. Well, that's kind of curious. And if you go a little bit further, you might say, let's do that. That's invalid as well. And we'll pull this line off so you can see that's invalid as well. So there's something here that you're missing. Now, you're very smart, and you've learned a little bit about computer science in school, and you say, you know, I know Python is driven by a grammar. So you go into the grammar file in Python, and you can see all the details of how the Python grammar works. And you can answer some of the questions that you found by just digging at this layer. Here you can see part of the Python grammar, the specification, that's not only a specification for how Python parses itself, but is actually used as part of the code-generated parser. It's actually used as part of not only the CPython code that parses your code, but also the Python library that can give you parsing support. And you can see there's this atom thing. And you can probably assume that that atom thing represents the smallest unit as part of some expression. And you can see a name, a number, a string, and an explicit ... none, true, or false are all special case. They're all separate from each other. And if you go further, you can see that there's this expression statement. That's what happens on the left and right-hand side of the equal sign. But you can't see anything here that actually stops you from assigning to that ... And you might begin to wonder, what's stopping me from doing that assignment to the ... either in the first case I saw yesterday or in the recent case I saw today? Now, you might know that Python allows you to parse itself. It's a really neat thing about Python. Your Python distribution comes with a parser that allows you to parse Python code, which is why Python tooling is so great, because in a tool like my IDE here, I can actually use the current version of Python that I'm writing code in to also verify that the code that I'm writing is syntactically valid. Well, here you might say, well, I can parse something like this and see, oops. Let's do, I can parse something like that, and that works. And I can parse something like, oh, this is my Python 2 parser. We've got to be a little bit careful. There we go. I can parse something that looks like that, and that parses fine. I can parse something that looks like that, and that parses fine. When I try to parse something that looks like this, that used to work in Python 2. It doesn't work anymore. I get this can't assign to keyword error. Now, when I try to parse ... colon ... like giving a variable annotation to the ... I get this error. And when I try to parse ... equals ... I get that error. Now, I'm kind of curious, but I don't know a whole lot about how Python works, so I might just start grepping for those errors and see what I can find. And when I grep for the first error, illegal target for annotation, I can find this in the source code. This is the AST code for Python. If I scroll around a little bit, I can kind of see what's going on here. It's not too hard. Here, if I scroll up to the top of what this function is, this is some function that's used for validating or creating the AST for an expression statement. And you can see that when you do an assignment, the left-hand side of assignment can only be a couple of things. It can be a name kind, an attribute kind, but it can't be anything else, because otherwise you get illegal target for, this is an annotated expression, illegal target for annotation. And if you look, you can see the same reasoning for assignment for keywords. For example, if you look for that assignment to keyword, you can see that it also checks for forbidden names, and you can say, oh, this is why I can't assign to true, false, or null. It specifically says, oh, is the name you're trying to assign to true, false, or null? It's a forbidden name, you get that error. But the weird thing is, when you look for can't assign to ellipses, your grep doesn't give you anything. Let's try that again. There's nothing there. And when you look for can't assign, that error, there's nothing there either. And so you're kind of curious, but you're precocious, you're smart, and you know you can always dig deeper. And one way that you know you can dig deeper is find something that you know will get hit, run it under a debugger. So what we're going to do is we're just going to go back here. And what we saw here was this AST error. Why don't we just put a breakpoint on AST error, try something that we know will fail, and then see what happens. There we go. We hit our breakpoint. Let's look at a backtrace of that, and we can kind of see where we are. Here we have the AST error, can't assign to ellipses. OK, in AST.C 681, that's defined by, that's called from set context. And if we go to that line, we can see why we couldn't grep for it. This error message is actually automatically constructed, because there's a couple of things you can't assign to, and they just automatically construct this. Now, if you look a little bit higher here, you can see what's going on, which is every time you try to do an assignment, it depends on the context in which you're doing the assignment. When it does this set context, it looks and sees, is this a valid assignment? And in this case, it's not. So you get that can't assign to ellipses message. Now, one thing that's interesting is that doesn't answer why we can't assign to the ... as a single Unicode character. If we go back to the error that we saw there, when we try to do the assignment to the ... as a single Unicode character, we get a different error. We get invalid character and identifier. Now, that's something that we can grep for. And if we grep for that, we see this line here, error input. So if you scroll around, if we grep for this, we see quite a few answers here, and we can see in Unicode object.c we have invalid character. Now, if we look around a little bit, and we can also see this Python run.c, invalid character identifier. And if we look at that, it doesn't really give us anything that interesting. This error shows up here. And this kind of shows up as like a grab bag of where errors get produced. So it doesn't really tell us anything interesting. It's like error input. So some error function calls out here. So knowing that didn't really help us. Instead, what we're going to probably want to do is we're probably going to want to debug this. And we'll just put a breakpoint on error input and see what happens. And we'll continue. And then we'll try to assign to the 10. And we'll see what the backtrace of that looks like. And that's not actually very useful. Because it turns out that whatever was stopping us from assigning to the ... as a single Unicode character is called directly from the parser into Python run. It doesn't tell us any information about where we got stopped. But we know a little bit about compilers. So we go back to the basics and we say, you know what? I know that I've looked at the grammar. I've looked at the parser. There's something else that's missing. The tokenizer. The thing that turns the individual characters into the tokens that get fed into the parser to generate the AST. And if I look at the tokenizer, there's a function called token get. And if I look through that, I can kind of try and figure out that there, if I scroll down a little bit, I can see there's a function called isPotentialIdentifier_start. That's kind of useful. And if I scroll down a little bit more, I can see a function called isPotentialIdentifier_character. And I can see a function called verifyIdentifier. I don't even know what these things do, but it looks kind of interesting. And if I try and figure out where those functions are defined, they're actually defined at the top of this file. And if I look at that, I say isPotentialIdentifier_start. So this is trying to determine if a Python variable name has a valid starting character and a valid continuing character. Well, this says any Python variable name starts with a letter between A and Z ASCII lowercase, A and Z ASCII uppercase, or anything above 128. You know, these are Unicode characters. Of course they're larger than 128. They can't fit into a single, they're not ASCII characters. They don't fit into the ASCII code page. Same thing with isPotentialIdentifier. So that's not a valid lead. But if I go into verifyIdentifier, I may see something kind of interesting. In verifyIdentifier, if I scroll down a little bit, I see PyUnicode isIdentifier. Well, that's kind of interesting because I might have actually seen this in use before. When I was bored one day, I probably did a dir on a string, and I saw a bunch of stuff in here that I probably never really used, like .ljust, .rjust, but there's an isIdentifier right in the middle there. And it turns out that Python can actually tell you, is a string a valid Python identifier? Oh, XYZ is a valid Python identifier. This string is a valid Python identifier, right? But that's not. So I've gotten a little bit closer, and I can see how Python helps me in this regards. I've gotten a little bit closer, but what I need to know is what happens there. Now you can see here, PyUnicode isIdentifier. Let's go into PyUnicode isIdentifier and see what's going on there. So here I have the code for PyUnicode isIdentifier, and suddenly I see something quite interesting, PEP 3131. Usually I don't care about PEPs, I don't read them, I just use the features. But let me actually dig into the documentation and see what this thing is all about. And it turns out, if I look at the PEP for this, I can see PEP 3131 supporting non-ASCII identifiers. Look at the author and try and guess why it is that he really wanted to get this PEP in. And one thing I want you to notice is look at his name and look at his email address. Do you ever wonder why French people, when they write their names and email addresses, they don't swap out the accent aigu or the cedilla for some other repeated character? German people will change the umlauted O into an OE, or they'll change an S set into an SS. So French people really care about this idea, except when it comes to writing emails to them. Don't ask me why that is. I told you this talk has no theme. Now, we might know a little bit more about what this thing is talking about. If we look at this, you can see it goes on and on and on. It's a really long PEP. It's incredibly boring. And in here somewhere, it mentions this thing XID, XID modifications, XID start, XID continue. And I know a little bit about Unicode. I know there exist these things called Unicode categories, and I might have seen them before. This is a way for the Unicode standard to categorize characters. So, if I look at a couple of interesting characters like this, I can see that if I look at a couple of interesting Unicode characters like this, I can see the lowercase a is an LL, letter lowercase. The uppercase A is an LU, letter uppercase. The number 1 is a number, probably D for decimal, I'm guessing. The 1/2 is a number other. And that dot, dot, dot in the end is a PO, punctuation other. But none of this seems to refer to whether it can be part of a valid Python identifier or not. Now, one other thing I might know about Python identifiers is I can actually write them out. So, we have our ellipses, but I can actually write out Python identifiers and Python strings like this. And so as I start to play around with Unicode, one thing I might want to do is I might want to print out, if I'm working in optical engineering, there's a lot of special Greek letters that are used to reference this and that, and I might not be able to type them on my keyboard, so I can use the /n in order to type them. Now, before we go on, I want to ask you one very important question. When it comes to Unicode, there is only one thing you ever need to know about Unicode. It is the most famous, most popular, most important Unicode character in the world. What is the pinnacle of Unicode, the apex of the standard, the most important Unicode character ever created? Obviously. Now, the reason I really wanted to bring that up for you is, as I've told you, this talk is a real talk that took an enormous amount of time to put together. And it's very important for you to understand why it is that the talk exists as it does. The reason is we're running PyData New York this year on a weekday, which means many of you have taken valuable time off from work to come to this event to see talks like this. And many of you may have taken off 3 days of work to see all the talks yesterday, today, and the tutorials tomorrow. And your coworker will come to you tomorrow or Monday and ask you, how was PyData? How did it work out? Do you see any good talks? And you're going to say to them, well, I saw a couple of talks about Dask and Numba, and then there was this one talk that was about... So maybe when they ask you if you saw any good talks at PyData, maybe skip this one. Now, when you go back to PEP 3131, you might realize that it's very much in depth, but you kind of look at your watch, you look at the time, it's 5 o'clock, it's time to go home. That's enough for today. But when you come back the next day, you've exceeded their expectations. Your boss is out on an offsite. You don't really have any tasks today. You're left to your own devices. And you go back to that PEP, and you kind of scroll through it, and you say, there's some links at the bottom. And there's this link here, derived core properties. And that might give me some insight into what this XID thing is. It's just one text file. And if you look through it, and you look for XID start, you can see that the Unicode standard actually gives these derived properties, like tags, for every range of Unicode characters. And these are all the Unicode characters that are valid as part of an identifier, the start of an identifier. And if you scroll down, these are all the ones that are valid as part of the continuation of Unicode identifier. And you have some free time, so let's write a little bit of code to parse that file. We'll download it, we'll parse it, and we'll see what is a valid Python variable name. That's where we got to in the first place. We couldn't do ... equals ... no matter how we typed it. So let's see what we can do. Well, we're looking for everything we'll look for the beginning of a character, so we'll just look for everything where XID start is in it. There we go. So here's all the XID starts. Now, we'll just grab the value out of this. We'll just grab the value out of that part. OK, so those are all the values. And if it's a range, and these are hex values, so there we go. So those are all the ranges there. Otherwise, we'll set these to the same. And then we can just go through these. And we can see if there's anything interesting here. Now, if we print these out, we probably want to print out the hex value, just in case somebody asks you for that. We'll print out the name of the character, and we'll print out the character itself. And we'll see, is there anything interesting in here? Anything that we can use to basically waste the time until the boss gets back from vacation. And we'll put a little sleep at the end here, just so that when we print this out to the screen. OK. So we've seen those as part of identifiers before, Latin, small characters, and upper characters. And it takes a while for us to get past these. So you know what we're going to do? We're just going to skip anything with Latin in the name. And we get to see some very interesting things that Python allows to be valid identifiers according to XID start and XID end. A lot of different characters, but you saw those modifiers. And that's very interesting, because it turns out that a couple of things are valid identifiers. Here's a joke when I gave the first version of the talk that nobody liked, but I liked a lot. So the double struct capital N. No, I want to do. Yeah. So the double struct capital N is a valid Python identifier. That thing, let's see if I can get this. Because some of these are very hard to type. That one there, that's a valid identifier. The double struct capital Z is also a valid identifier. That's one. The capital R is also a valid Python identifier, which means that if you wanted to be really tedious, you could write something like that. Right? And the joke I really liked was this. Because type annotations have to be useful for something. Now this isn't valid, but thank goodness we have some future import annotations. So I like that joke. I don't know, nobody else did. But what's really interesting is other things are valid Python identifiers as well, like the Greek small letter pi and the ideographic number 0. So this should be valid Python. Let's take a look. For some reason, this works. But it shouldn't. Why not? Well, that pi r squared shouldn't actually work there. Let's take a look and see what's happening. Because that's not in our list. That's not in our list. Right? And something weird is happening here, because on that line there, I forgot to type the squared as an uppercase, and it still worked. And it works both ways. I wonder why that's possible. Well, it turns out that square character is not XID start. It's not XID continue. It's a numeric other. It doesn't have that tag at all. And if we go back to what we know, which is that we have the standard here. And in the standard, this very boring standard, it tells us about what is a valid Python identifier, XID start or XID continue. And it goes on into more detail. And it says here, again, XID continue closes the set under NFKC normalization. It turns out that Python will also try to normalize your identifiers. And NFKC normalization, if you read about normalization, is one of the very normalization forms. Here you can see an example of it from Unicode document, and it decomposes it, then it recomposes it in order to get a canonical form for these characters. And it turns out that that's something that's done as part of your Python identifiers. Now, if you go into Unicode data and you look at the normalize function, you can see it here, Unicode data UCD normalize. And if you try to figure out if that thing is ever actually used, we might go back into our GDB and put a breakpoint on that. Right? And we might continue, and we can see if we do x equals 10, y equals 10, it doesn't get used. So it doesn't get used if your variable name has only ASCII identifiers, but the moment I do that, hold on a second, it didn't get hit. So it didn't try to normalize it. It still gave me this invalid character identifier. But if I try to do this with something that I know is a valid Python identifier, like an interpunct, valid and XID continue, it does get hit, and I can look at a backtrace, and I can see where I am. And if I look at that backtrace, I see Unicode data, UCD normalize gets called from py method, raw fast call dict, blah, 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 blah. Something interesting right here, new identifier. And if I track that down, and I see where I am, I can see that there's a function called new identifier. And new identifier is what actually performs the normalization. Well, in the original code, it was NFKC. If we just make 3 edits to make any NFKC to NFKD, and go back into our old friend, is Unicode identifier, and just comment out the part where it checks if it's XID continue, and recompile our Python interpreter, then anything is possible. And so it's right surprising that that just works. And so now I have a Python interpreter where anything's a valid variable name, including x squared, which is equal to x2, because sometimes you're lazy and you want to write it big, sometimes you want to write it small. It's up to you. And when you take that back home with you, you'll remember, this is valid Python. This is valid Python. Now we know that this is valid Python as well. Right? Now we know that, we have to do from future import annotations, and I need to fix this. Sorry, that wasn't valid Python. This needs an arrow. There we go.
Future.
Thank you. There we go. So that's valid Python. And we know that we can add some interpuncts in here, some middle dots. So that's valid Python. And if we look really closely, we can see some other really interesting stuff, like modifier letter prime is also XID continue. So that's valid Python. That's a prime, not a quote. Take that to work with you. And it turns out a whole lot of interesting things are valid Python syntax that you never expect them to be. And so, at the end of the day, you might end up with something kind of interesting. It might look like something like this. It makes total sense. I mean, this is all valid Python syntax. Python's a very easy language. It's not syntactically very difficult to understand. Anybody can really parse it just by looking at it. It's not as bad as any of that other stuff. And really, really, honestly, let's be honest with ourselves. This is quite obvious. Because if you look at it closely, it's just a function named f that has a single argument that's named underscore, that has a variable annotation, that is the twice plus unpacked dictionary of a dictionary that maps an ellipses to a negated ellipses raised to the power of a double underscore, that returns as part of its function annotation a dictionary that maps ellipses to ellipses, that just has as its only expression in it a variable that has a bunch of interpuncts and a dotted lookup, whose variable annotation is a ellipses mapped to an ellipses. What could be simpler? And you know what? Look at the time. It's 5 o'clock. It's time to go home. Thank you so much. That's it. There's no questions.